The equations for the 45-degree launches were largely the same, the only major difference being that instead of using 90 degrees for theta, we used 45. Characteristically for our group, a multitude of things went wrong. Seeing as earlier we had lost all but one of our nose cones, every launch came with a good deal of apprehension as to whether we would be able to find the rocket and recover the nose cone. If we had not recovered it, we would not have been able to carry out any further launches. In addition, one of our launches went pathetically wrong, as the rocket only took flight for about a second and flew for a total of around 20 feet in the x-axis. As it turned out, we were able to obtain 2 usable launches and collect the necessary data. If we had attached the nose cones with a screw and bolt to begin with, our launches would have been much more successful from the start. Using nose cones with identical weights and completely symmetrical shapes would have benefited us and resulted in potentially perfect results. Thus, we learned for future projects to review all possible options and to test out our product before using it in the actual lab setting. This will help with other projects, in and out of school, that should have a test run before being actually tested. This also applies to papers for school, which should be reread by both the writer and by an outside source before being deemed complete. If we had attached the nose cones with a screw and bolt to begin with, our launches would have been much more successful from the start. Using the nose cones with identical weights and completely symmetrical shapes would have benefited us and resulted in potentially perfect results. We again used the formulas for range and distance. We used the same method to find time in the air. We then used 32 feet per second squared and 9.8 meters per second squared for g and found vi by using the formula for acceleration off the shaft. Finally, we used 45 degrees as stated instead of 90 degrees. In this section of the lab, the group got along well. The only trouble we encountered was returning for another launch, which only 2 members were able to attend due to classes that conflicted. However, the 2 members who launched the rocket were able to fulfill all necessary tasks with a limited number of hands. We found it stimulating to be able to predict the general range in which the rocket would land. It provided a basis for comparison regarding how well our rockets performed, and it also gave us a general idea about what would happen when we completed the lab beforehand. As in the 90-degree launching, we did not like the weather dependency and wind dependency of the results. It was inconvenient because the rockets could travel much farther or much less far due to outside vectors. This lab is good preparation for future projects of the same nature and of differing difficulty. Through it, we were able to apply our prior knowledge of physics and to learn new, more interesting applications for said knowledge. Thus, with other parts of the lab, 45-degree launching should be kept to demonstrate the relationship between it and the 90-degree launching and to provide a basis for prediction and comparison.